welcome. Okay. So welcome everybody to this session to Introduction to Project Management using At-Risk. My name is Gustavo Vinuesa. I work for Palisade Corporation for 5 years now. And I'm really glad I had to speak during this webinar because this is a topic that I like a lot. We've done lots of consulting gigs using project management and At-Risk, and it's really, really helpful. So during these 60 minutes, I will try to focus on showing you the major capabilities of our software regarding project management. Yesterday, we have an initial cost estimation webinar using At-Risk that could be considered part of the project management as well, right? Because you talk about budget, you talk about uncertainties in prices, you talk about risks that could appear during the execution of the budget. Now we're going to focus on a different part, which is the Gantt chart, right? The execution of the project. And here are the main goals of our presentation today, right? First of all is a basic understanding on how At-Risk can help you manage the uncertainty in your project schedules, right? At-Risk has a native MS project integration capability. That means that it is going to read automatically your MS project tasks, and it's going to import them into Excel, and then you will be able to add uncertainties to them. And some secondary objects derive from this first one, which is how to model your project schedule, how to set up and run simulations, how to generate powerful graphics and reportings, to calculate probability of success, graph the margin of error, etc., etc. Right? I'm going to start with 3 slides talking about schedule risk analysis. I will send you the presentation, so if you can contact Jameson after the presentation, he will be able to send you both the PowerPoint file plus all the Excel and MS project files that I'm going to use during this presentation. Okay? So this material is for you. Thanks again for coming. Right. As an introduction, and I assume that you all are in the project management industry, you know that that the variability is a constant. You work in a changing environment. Normally you have cost and duration estimates, which are point estimates, right? Which is you get the average, you get the biggest of the 3 last quotations. You have hopefully some historical database, but normally or traditionally you have point estimates there, right? What is the issue with the point estimates, right? Is that they are not able to reflect the volatility or the variability or the complexity of the duration, in this case in the project execution. In the 50s, 1950s, what came up was PERT, right? Project Execution Review Technique, and they proposed a 3-point estimate, right? That used minimum, most likely, and maximum, right? And that lets you calculate a given duration based on this formula, right? Also, they were able to calculate the standard deviation. That means the risk of the particular task. But again, what happens is that you come back to the expected duration, right? Which is this. You go to the expected duration, and you don't go to a distribution. So that means that at the end, it was an estimate that was derived from a calculation, but again, it was just an estimate. But this is a really, really good beginning because this is the distribution that we're going to use, right? Also, there were some assumptions there that the duration, they assume to be independent, which in reality they are not. They should follow a beta distribution that perhaps they don't. And they assume that the critical path, right, for all of you project managers, that the critical path found by the critical path management, right, which was the other technique that was invented, will be always the critical path. So we're going to break some of these assumptions during this presentation, right? First of all, when you move to an stochastic risk management, what's going to happen is that instead of having just one number, one particular estimate, what you will have is a range. Is a range for the task, right? So you will be able to say, I'm going to take, like for example here, between 10 and 20 days for the duration of a particular task. And this is a PERT distribution, you see here. And this is a PERT distribution that uses the exact same parameters it used before, but you will have a distribution. So during the simulation process, when you run the Monte Carlo simulation process, this is going to get samples from any part of this distribution based on the frequencies of each one of them, right? And it's going to generate and recalculate the total Gantt chart every time. So the output of the Gantt chart is going to be a distribution itself. So this is the first change, right? Because we are adding a new dimension to our problem or to our calculation, which is the probability. Before, we didn't have that, right? Additional benefits, it overcomes the limitations of CPN and PER that I just talked about. Independent tasks, duration. Here you can add correlation matrices. You can use randomly generated numbers to determine the activity durations. You can have what we call a critical index, which is how critical is an activity, because you have many different critical paths. And I can use even a probabilistic or conditional branches, right? And all this is going to take me here, right? And I'm going to use this graph to explain what we're going to achieve today. Every duration of every task, or I would say every task has two components, right? One is the duration, which has uncertainty. That means a task can be regularly done. Let's say that you're, I don't know, doing the foundation of a house between 20 to 50 days, right? Depending on weather, depending on the resource feasibility, depending on the design, etc. Right? But this is under regular conditions that can take between 20 to 50 days, let's say. But also you have a component which is represented here by these red triangles. And these components are the risk occurrences. Risks in this case are very low probability but high impact events that could happen and could affect the duration of the task. What happens if, for example, you're doing the foundation of a house and then you find some, I don't know, archaeological treasure, or you find some pipe, some water pipe or a gas pipe that was not in the blueprints. So you will have to stop, and then the duration is going to go to the right? It's going to take longer and longer. So what we're going to do during today's session is to help you understand how at-risk can add both the uncertainty and the risk event to your analysis, right? In terms of questions, what's going to happen, you can send the questions to Jameson. I'm going to do 2 or 3 stops during the presentation so I can answer the questions and hopefully the context is still valid, okay? Now, in this presentation, in the section that reads at-risk for project, it's a description on how at-risk uses the MS project native capabilities. I'm going to show it to you, so I think it's going to be better, but you have there for further consultation. Okay, so the first thing, we're going to load at-risk, right? As you know, at-risk is going to be open in Excel automatically, and it's going to add a new menu here, like this, right? And you will have this section here, which is called project, right? So what I'm going to do, I'm going to import an MPP project. This is the MPP project that I will open. This is a regular MPP project, as you can see here. Right? It has tasks. Hopefully, well, in this case, let me see. In this case, you don't have resource names. Hopefully, you can add resource names. You have all the interconnectivity among them, etc. Hopefully, you have some parallel tasks, some star as well, like here. So you can put all the burden into at-risk. What I'm going to do, I'm going to import this file into my at-risk. You will see how it works. So I go to project, import. I'm going to select. You see that automatically it opens MS project. Right? So I'm going to open it. See here. It's this one here. And what's going to happen, it says, well, do you want to review or change the import settings? I will say yes, to show you what you can do. So first of all, do you want to import this to a new workbook or to the Arctic workbook? And I'm going to say to a new workbook. Where am I going to get the information from? For example, the task table is from the entry table, the resource table as well, right? And this, if you use at risk 4 for project, well, if you use at risk 4 for project, you will remember that everything was in project. So this is a big change, starting at risk 6, where you have everything in Excel, right? So I will click on OK, and this is going to read, you'll see here, this is going to read the 20 tasks and resources, and it's going to import. It says, do you want to save the workbook? I will say yes. And like this. Now you can see it. You have all the different tasks here with the duration, the start and finish date, the predecessor, and also you have a graphical section where you can see even all the. See here. Give me 1 second. I'm trying to move this menu from the GoToMeeting. Here you go. And then you have all the tasks, duration, the interconnectivity, the milestones, etc. Right? That is imported there. So what happens is that now this Excel file has a heartbeat link. We call it that way, a heartbeat link with project. That means that if you make a change in this project, like for example, testing is going to take 2 months, right? Like that. And I go and say project sync now. You see, now it's 2 months, right? Also, I know that you can do the opposite. For example, change it here to 1 month, and this is going to update. But my preference, my recommendation is that you give each one of the platforms it's a specific purpose. So our recommendation is for you that you model everything in project. You model the Gantt chart in project, all the durations, all the predecessor and successor, start, finish, etc. And here you model the uncertainties. You can see also that you cannot generate new tasks. For example, here you cannot insert or delete. Also, you cannot insert or delete here, right? Because this is a special sheet where you have this link, right? You can add much more sheets, you can add much more things, and this is still an Excel file, but this particular sheet is going to be linked with the Gantt chart. Okay? Now, how can you add some uncertainty to this? What if I'm going to say, well, the site selection is 1 month. What if you know it's not going to take 1 month because you have some difficulties there? So perhaps, and I'm going to define a distribution directly in this duration distribution, and I will say this is a per distribution, right? And I say this is going to be between 1 month with a most likely of 1.5 months, and it can go as up until 3 months, like this, right? So you see that you have a bias here, right? You have a tail here, right? And what you were able to do, you were able to transfer to your Gantt chart uncertainty in the form of a distribution. So instead of having a point estimate, now you have a distribution, right? I can color the cell, so that means that I know which are the distributions. So for example, here, so what's going to happen, you know that this is a very simple Gantt chart, and this is part of the critical path, right? So what I'm going to do, I'm going to start the dice. I'm not sure if you're new to at risk, you will see that you have this dice that's going to allow you, being the user, to generate samples like this. You see? It's 1.36 months. Take a look, please, to what happens here. Right? 1.73, 1.91, 1.58, you see? So what this is doing, this is changing the Gantt chart, and at the same, because this is pushing all the tasks to the right, and at the same time my duration is changing, you see? 26 months, 26.2, 20, you see? Every time my duration changes, right? 26.35, etc. Right? So that means that by changing only these site selection tasks with only one distribution, I was able to add uncertainty to the Gantt chart. I'm going to do the same with land procurement, right? Define the distribution per distribution, right? I'm going to say between 2, 3, and 5 months, right? I'm going to add lots of uncertainty there, right? And you see that this is still an Excel sheet, so I can save it. It's going to save automatically. It's going to save it like a regular Excel sheet. But, and this is really, really important, and before I run any simulation, I need to make sure that you understand how the files are going to work. The next time that you want to open the file, you will open the Excel file with at-risk preloaded. So you load at-risk, you open this file, and this file is automatically going to open the MS project file. And because they are already linked, so you don't have to import the MPP file every time, because you already have had the chance to add some parameters to it, right? So this is really important. Let's go back to the model. You have here the site selection, land procurement. You have 2 distributions, right? Remember that every model in at-risk, you have distributions, which are the input, and you have the output. So the output is going to be, let's say, the duration. So I choose the duration and click on add output. So it's going to be the duration. You can change the name if you want. Duration. Anytime you can go back here. You see? It's a very simple model, so you don't have, I don't think you can even have costs. Let me see. I don't think you have costs. Hold on. You see everything, it's not resource loaded. This is a really simple model, right? And I can do, what I can do is I can start a simulation, and this simulation is going to, and I'm going to let you see it. Let me have at-risk and project open at the same time. Go here. See. And you will see what happens. Right. Let me move this to the right. So what you have here is the total duration graphic. You will see here is the Gantt chart, and you will see how it moves. You see? Iteration by iteration. It moves, and it generates a new calculation every time. Right? So I just asked for 100 calculations. If you've used at-risk with Excel only, you see that obviously this is different in terms of speed. This is slower because you have to interact with project every time. How is this interaction going to be? Everything that has to do with the Gantt chart in terms of the calculation of the calendars, the duration calculation, the cost calculation, that is going to be done by MS Project. Everything that has to do with the sample generation like this, it has to do with at-risk, right? So what happens is that I ask for 100 iterations. That means that from these 2 distributions, I grab 100 samples, I send them, recalculate the total duration, and I have this distribution for my results. And what this distribution says, and then you will start to see the value of it, is that I will take, this is in months, from 25, see here, from 25 to 28 months to finalize my project. You see? I have more or less 3 months of variability. The expected value is 26 months, right? And also, I have the capability to select a percentile. So if I am very aggressive, I would say perhaps this is going to take me 26 months. I am only protected 10% of the time. If I am very conservative, I will say, you know, I am with the board of directors or with the sponsor of the project, and I will say, you know, I need money for 27.6 months. You see the difference? If I'm aggressive, 26. If I'm conservative, 27.7. Right? So perhaps this is the owner, the fund, the owner of the funds, or maybe the boss, and maybe this is the project manager. Right? This is normally what happens, and you have to struggle sometime in between this band in order to see what is the final number that you will pick. Right? What is your risk profile? Let's say it's 70%. Right? Now, what is the good thing? The good thing is that you didn't have this before. You got only one result and one result only. So it was very difficult to sell the idea of, well, let's give me 1 month. Why? Why is not 2 months if you have a very conservative boss? And if it's very aggressive, why only 1 week? Now you know that if you get these 1.7 months, you will have 80% probabilities on your own. You will buy this risk for you with 1.7 additional weeks, right? I don't know if we have questions, Jameson, so far?
We do have a question here.
Please go ahead.
Yeah, a couple are coming in. There's one. The new product total time states 24 days, but duration pop-up window has a different number, and 24 is not mentioned at all.
Oh, here. So let me yeah, it's a really good question. So this is what happens. When you are running the simulation, this number is going to change. Let me show it to you. See, every iteration, you see now it's 26.991, 2668, 2695. You see, when I disable the dice here, this 24 months is the expected value of my Gantt chart, right? It's given the parameters of my distributions plus my static values. This is what is expected to happen. So you will see here, if I browse results, that what happened in this case is that my expected value was too low, because what I did, remember, is that my minimum here was 1 and my minimum here was 2, and those were my expected values. So this is what happens, right? I just changed, because what the expected value does, it takes this risk static, right? So for this calculation of 24 months, it goes to the project field balance, and that means I'm going to project, and I'm going to take whatever number I have here as the one that I'm going to do the calculation with, 1 month and 2 months, right? If I eliminate that, let me do that for you. Eliminate this risk static. It's a really good question. What's going to happen is that, you see, this is going to be the expected value of the model. Before, I have whatever value you have there, so it has a priority. Now in this case, this is the real value of the model, right? 1.6, 3.1. Okay? So what I have to do, I will have to refresh it, right? But what happens is that the parameters that the model was using, right, they are all connected to this now, and it's really, really important. Here, this duration result is only for modeling. Here, you won't find the answer, any answer. This is the output. You have to go to browse results, and here you will find the answer, here. Because you upgraded your model, now you raised the level of your model. So now you're talking in statistics, you're talking about the mean, that this is going to be the expected value given the distributions, and these are going to be the risk profiles. So hopefully I was clear enough. I can repeat the explanation if you want, but that's what happened, right? That it's first it is connected to project, and second it was taking the values from project. I can eliminate the risk static property, and this is going to take the expected values. Okay?
Good.
Okay? So
Good.
this is the first thing, right? This is a very simple example. And what it lets you do, it lets you generate distributions for each one of the tasks, right? So what if you have, and I imagine that if you're a project manager, you will have hundreds of tasks, right? So doing this one by one is really, really cumbersome. So what you can do, you can go to project, model tools, risk categories. So you have two options to do it in a more than one task way. So risk categories, what I can do is I can select, for example, a high risk category. This high risk category, let's say I'm going to use a PERT distribution, that's going to be minus 5% plus 50%, right? These are high risk tasks. For example, this is a new technology, or is a complex environment. This is on-site in very heavy weather or something like that. And this is going to affect the duration. So what I'm going to do, I'm going to add all the tasks that I consider high risk. For example, this, let's say. These 4 tasks, I am considering them high risk, right? And all of them are going to have this distribution. And this distribution is based on the current value they have in the Gantt chart. The minimum is going to be 5% less, and the maximum is going to be 50% more. Right? I will click in OK, and you will see how automatically these tasks, they are replaced with this risk vary option, right? With a per distribution with all the parameters that I used. Right? Obviously, what's going to happen if I run the simulation again, you will see, is that instead of being between 25 and 28 months, the duration now will be between 26 and almost 30 months, right? Because I added this uncertainty here, right? This is one way to do it. Let's imagine that you have 300 tasks, 500 tasks, etc. Right? And also you have another option, which is go to Model Tools, Parameter Entry Table. And what this is going to let you do is going to let you add some parameters internally in the Excel sheet, like this. So I'm going to show, let's say that I want to add all these tasks, for example, all these 4 tasks. Let's see here, these 4 tasks, right? I'm going to add a per distribution, minus 10 plus 20, right? Let's say minus 5 plus 20, right? And you will see what happens. Right? What this is going to do, you see, it added automatically the parameters for these particular distributions, right? And these distributions, the definition of these distributions are based on these parameters. So you will see here that you have a per distribution which is linked to these parameters. You see? You have a per distribution linked to these parameters, a per distribution linked to these parameters. You can change this freely. This is Excel. So you can change this to be, I don't know, 4, and you can change this to be 9, and you can change this to be 12. And I can run it again, and you will see that obviously I'm adding more and more uncertainty, and I'm being more and more pessimistic. So now you see that I have between 26 and 31 months, right? Remember, I started with 25 and 28, right? But this is something that I can do. See, I can open a file that has many tasks, and then you can select using the model tools, the risk category, right? I can do something like this, add, and I can choose with control like this, right? Or there's a really, really nice option. This is a little bit advanced, but if you have an Excel sheet where you have something that you mark, for example, critical path, or you mark as really important tasks, you can add something that is marked, right? So I can select a cell which contains the identity task to this category. So I can say, let's add all the ones that are, I don't know, critical. And then automatically takes from all your tasks, all the ones that are marked as critical, or any flag that you have here, right? So it is really, really, it's a really fancy feature, right? Not very, very much used, but it's a really fancy feature. What else you can do here? You can define more categories. So you can have high, medium, low, etc. that are going to help and make your life easier, right? So now what we did, remember, we added the uncertainty. We added uncertainty here, we added uncertainty here. We have our output. What else we can do with our output, right? We have our PDF, right? That's the probabilistic density function, but also we can get some tornado graphics, and these tornado graphics are going to give us which are the main tasks that I should focus in if, for example, this is taking too long. So instead of having to focus in all of my tasks, I can say, well, I will start with this first 3, because these are the ones that affect most my result, right? And now I know my result is negative, right? It's pessimistic. So I can do that as well, right? I have different tornado graphics. This is a regression. This is a correlation, which is almost the same. And you have also change in output mean, which gives you what is the impact of, for example, land procurement. It says that it has the bigger impact in the duration, and this is the scope. This is how much it would change if you have a very low land procurement or if you have a very high land procurement, between 27 and 29 months. This is the scope. This is the scope of the action if you change with a big shock to land procurement, which is really different from engineering design, which can go between 28.1 to 28.7. Okay? So this is what you can do with uncertainty. A couple of additional things before I go to the risk register. A couple of performance tips, right? Because so in this case, I have, let's say, 20 tasks, right? The moment that you have 500 or 800, this sometimes takes a lot, and the more complex your Gantt chart, the more time is going to take. A couple of things that you can do. First, when you go to project settings, always try to check the engine and see if your project fits into what we call accelerated engine. The accelerated engine, what it checks is that if the logic of your Gantt chart is able to be simulated in Excel, that means that parts of the Gantt chart are going to be simulated in Excel, so that means that you don't have to, every iteration, go back and forth with project, right? This is one thing. If you don't need them, eliminate the calculation of the critical tasks and statistics, right? I'm going to show you right now what it is, so you will see if you need it or not, right? Another very easy tip, here you go to project. Everything here is in the project menu. You can go to project, charts and reports, and you go to standard Gantt, right? And what you can do, I don't want to display the Gantt chart in Excel. Nothing will happen if I don't see it. I can choose if I want to display the links or not, the time scale units, the start date. If I disable the Gantt chart, you'll see that it is just an Excel sheet. And the results are not going to be changed at all. So it's going to make your life easier, and you don't have to wait for the refresh of the graphic, which is always good, right? What else you can do? Let me see here. You can eliminate extra columns that you have here if you want, right? And I will wait here because this is a very simple sample, but when you do the schedule audit, and I will show you with another example, right? What this is going to do is going to check for potential issues in your Gantt chart from the risk propagation point of view, right? So this is not a Gantt chart checker. I mean, it's going to help you with that, of course, but the main point of view or the perspective that this checker uses is risk management. And for example, here what it says is, in task number 4, you have no predecessors. So that means that if you have a risk distribution defined before this task, right, and perhaps this task is part of the critical path, that means that it's going to be broken. The change of risk propagation is going to be broken, right? This is one thing. For example, positive lags. You have 3 positive lags here. Not sure if you can see them, right? These 3 months here, 2 months here, 3 months there. And what it says is no uncertainty can be specified for the length of a lag, right? So for example, if you have a lag of 3 months, what it says here is that perhaps now that you have uncertainty, you will have to make a new task for the lag, right? Unless you're 100% sure that this is going to take 3 months, perhaps it's a good idea to generate a new task that is going to have uncertainty as well, right? If you don't do it, let's say that I'm saying what I did, this is kind of an audit control, right? I just have to click here, and that means that I took care of it, right? It doesn't have any influence over the model, but it's only for you. This is a control sheet. If you don't do it, what you're basically saying is that this task and the previous task, or the next one, in this case, this is a start, are going to wait exactly 3 months every time, right? And you have to have a very strong reason for doing that, now that you have a tool that's going to make your life easier and let you define uncertainties for the times, right? So it's a strong definition. For example, in the case of lags, if you have constraints as no later than or start no sooner than, that's also going to appear here. And it's a good practice, it is a very good practice that as soon as you import the MPP, you go there and you go to schedule audit, right? It's a really, really good practice. So I'm totally recommending it here. Okay? Some of the reports that you can get, you go to project, chart and report, and you go to probabilistic Gantt. This Gantt chart is going to show you the same Gantt chart that you see here, but it's going to include some statistics. For example, let's say P10 and P90 for each one of the tasks. I want to display my critical index, and I'm going to highlight the critical index bigger than 70%. So let me explain what the critical index is. As you have in this case 100 iterations, that means 100 different Gantt charts recalculated every time. What's going to happen is that the critical path could or could not be the same in every iteration. You can have this case here. Let's say that this is a task, then you have other task here, other task here, right? So this task goes like that, and this task goes like that, right? And both finish there, and in this case, for sure, this is a deterministic Gantt chart, so this is going to be the critical path, right? This, after this, and after this. Right? What could happen is that, let's use the same example, is that you can have variability here, right? You have this like that, and you have this like that, right? And this could be very variable here. Let's say that you have all these possibilities, right? So tasks B, let's call this A and B. So task B can be so variable that perhaps it's going to last longer than A. So that is going to push C, right? This is going to be C. It's going to push C. So the critical path now is going to be this, and then it's going to be this, right? Instead of going this and that. So this is what happens when you have uncertainty, right? That if you have high volatility in tasks that have such situation like the one that I explained, you can have multiple critical paths. So the critical index is a property of each one of the tasks that tells you the percentage of the iterations in which that particular task was part of the critical path. So what happens is that, for example, this could be a critical index of, let's say, 80%, and this task can have a 20%. Why? Because only 20% of the time the critical path was like that, but 80% of the time the critical path was like this, right? So now you have a different way of seeing tasks, right? Because before you have a flag that said it is a critical task or not. So in this case now you have this critical index that I'm going to show you, and you have to have a threshold to select which tasks you're going to take maybe a deeper monitoring because they are critical tasks, right? And you will do that with a critical index. So what this is going to do is going to generate a report such as this that's showing you first what was the original one, right? You see in blue, that was the original. And starting with these little red pipes here, you see the minimum and maximum of the duration of the task, right? You see this is, if I'm not mistaken, P10, P90, this is the first interquartile, the third interquartile, but basically showing how volatile is each task compared to the ones that you have originally. Here you have the critical index. So you see there's no option here. In this case, the tasks were part or not of the critical path. Here, for example, the design complete 1% of the time was part of the critical task. So perhaps it's not worth it to focus on that as a critical task. Okay? So I'm going to stop here for questions, and I'm going to load another model. This is the model that I'm going to use to show you the different risk registers. So let me close this. I'm going to save that. Please, James, I don't know if I have questions.
Oh, sure. You answered quite a few of them in the last 5 minutes. That was great.
That's good. Great. I'm really happy.
Now, how do risk probabilities apply to milestones?
let me explain that with the model open. Right? I, for example, open here. Let me see what it says here. Give me just 1 second.
Sure.
I'm going to try to explain that with the model here. Here you go. Let me run it to see if that's okay, because I saw there was some type of warning. I didn't pay attention. So give me just 1 second. Okay. No, something is wrong here. Let me close and open again. So what happens with milestones? Milestones cannot have a distribution, right? They are just a consequence of some activity before, right? And the milestones are going to move, right? So you can put an output on the date of a milestone, and if that date has uncertainties that move that particular date, that date can be a distribution, but a milestone itself cannot be defined as a distribution. This is one thing. Another thing that is really important as well is that you cannot have distributions in the aggregate tasks, right? You have distribution. Let me see something happened here with the file. I'm sorry. Let me open it. I had another one, so let me see what happens here. Okay. Let me open this one here. Okay, here you go. So let me go there. So to answer the question, you cannot put here's the tasks sheet. So you cannot add distribution to the milestones. Like for example here, you cannot add it, right? Because you saw that it has 0 and 0, and they are not going to be affecting the total duration. And you cannot add distributions to the aggregate tasks, like for example this, right? You have to add distribution always to the task level. And this is very important. That's why you have the tools that I show you, right? The parameter entry tables, etc. Right? This is really important. It's really important because sometimes people want to do it on that, and you see no results, and this is why, right? So you always apply this to the task level. Again, if the task is a milestone, you will see that as it is defined as a milestone, it's not going to have any impact on the total duration. So what you can do is put this as an output. For example, in the aggregate, you can, let me see here, you can define this as outputs, right? So let me run it just once to see how fast it's running, right? And I'm going to jump to the risk registers. You see there, I'm not sure if you can see it, it says using accelerated simulation engine. So what I did in this particular model was to make sure that hopefully in my schedule audit, everything was working fine, right? Okay, so I'm not going to touch on the cash flow, but I'm going to touch on the risk register. Mm-hmm. Here you go. So now let me explain to you. If you were in yesterday's webinar, I showed a risk register that was a little bit more complete than this, that had the pre and post mitigation phases, right? And that was affecting a budget. So in this case, what I'm going to do, I'm going to show you a risk register that is going to affect a Gantt chart, and it's going to affect both duration and cost. Yesterday, it was only cost, right? So what is a risk register? It's a risk inventory. So you're in the project management field. Normally, you know what a risk register is. But if you're new to it, it's an inventory of risks, like for example here, that can occur to your model. Every one of them has a probability of occurrence, right? For example, 10%, 15%, 10%. One of the questions that we always get is, how do you calculate this probability? Normally, hopefully, you will have historical databases, right, that will help you calculate this. You have subject matter expert, SMEs, that you will pay, or hopefully they are part of your staff, that are going to lead you on defining this, right? you can get it from benchmarks, white papers, government statistics, etc. If you don't have anything on that, I will just suggest to use total frequencies or ask your subject matter expert, which is normally what they know about, right? But you need to calculate this. What happens with the qualitative risk register? When you have, this is high, very high, medium, low, etc., but you will have to translate that because lots of companies, they have these qualitative risk registers, but then at a certain point you will have to translate that into numbers. So you will have to define a scale where you say, well, very high is 80%, high is 60, medium is 40, etc. Right? This is done by using a Bernoulli distribution, and this distribution is going to look like this. You see, you have 90% probability of the risk not happening, which is 0, or you have 10% probability of the risk happening. Right? If you generate some samples here, you will see that every time, for example, here, risk number 2 happened, it had 15% probability of happening, and at the same time, it had an impact. That impact is here generated with a triangular distribution, but it could be a log normal distribution, a bird distribution, or whichever distribution you think is going to represent better the behavior of the potential impact of the risk. Why is it that 0 or 1? Because you can easily multiply this here, I6 times E6, right? Like this. Right? So when this is 1, for example here, risk 1 and risk 3 occur, the total impact is going to be $195,000. Now, these are single risks. I'm not going to go deep and explain what multiple risks are, but for sure you will have to change the distribution. Instead of a binomial or a Bernoulli, you will have to use a Poisson distribution that is going to have a compounded effect into the calculation of the impact, right? I can send you some information about that if you have multiple risks. Only for teaching purposes, I use this very simple risk register because I need you to know how the mechanics of linking this risk register to the Gantt chart work. Okay? Now, so what happens here and what is the way of at-risk doing that? You have the impact in money, but also you have the impact in days, right? This is really important because now you're working with 2 dimensions, money and time, right? So what we're going to do, we're going to link this particular risk, for example, risk number 1, that is going to cost $51,000 and is going to also make 2.1 additional days in our Gantt chart, and we're going to link that. So how do we do it? We're going to use this functionality here, which is called raise project at delay, right? And what it lets us to do, it lets us to link one task, right? For example, tasks B4, right? And it lets us define, let's see here, the delay length, which was 2.1 days, the total cost, 51,000, right? What is the predecessor task? Task B4. So what's going to happen during simulation time, remember this is task B4, this is the predecessor. So if the risk occurs, a task is going to be generated on the fly here. So this is going to be like that, right? And that task is going to take 2 days and it's going to cost us $51,000. You will see here that this project that I have here is resource loaded with money as well. So you will see changes in the total cost if the risk occurs, right? So the difficult part here, you will see that you have this risk project at delay, and also you have this, let me see here, you have these 3 risks that for sure, and I was going to go there, that you will have to also consider the mitigation cost, right? So in the total costs of the project, you will have to consider the original cost due to uncertainty, and I'm going to go back to this, right? The original cost due to uncertainty plus the cost due to risk register plus the mitigation cost, right? Because this is money that you spend in order to decrease the risk, hopefully, right? So what is the difficult part here? Because this example, it even comes with the software. So the difficult part here is to fill this, is to create a risk register that makes sense, right? That it's in an industry that follows an industry standard, that has probabilities and impacts that are real and adapted to the reality of your project. That, for example, you have a greenfield investment in a very hostile country, and then you want to reflect the risks. So instead of adding duration here that are really exaggerated, like from 1 to 12 months, what you will do, you will add a task from 1 to 3 months, and you will add the risk here with a probability, let's say, of 20% that is going to take from 2 to 8 months, right? So this is what's really difficult, right? To make a risk register that is reflecting the conditions of your environment, right? So what I'm going to run the simulation, and you will see what happens. Let me open both models, so you will see what happens. Let me make this smaller, like that. Open project, like this. And you will see that the risk tasks are going to be generated on the fly in the end of my Gantt chart. Let me see here. It's going to be something like that, right? You don't have to run it like this, right? This is just for demonstration purposes. So I'm going to disable the dices, run it in demo mode. Let me see, I don't know, 200 iterations, right? And you will see what happens. Let me see if I can show it until the end. Here you go. And run it. So I don't know if you can see here, these lines sometimes they go because these are the tasks that are generated on the fly and connected. Let me move this here. And connected to the different tasks linked in the risk project act delay. So you see here that these tasks are generated on the fly, and obviously you cannot see them during design time. So these are generated only during simulation time, right? And these are going to change the Gantt chart every time a risk happens, right? Let me do it. Let me run it faster. So you see here that the good thing is that the duration is going to be affected by the reality, right? And the reality is that you have sometimes things that are very, very low probability in terms of happening, but you have a high impact there, right? So let's wait for it, right? Here you go. So now let me open this here. Let me open Excel here. Open at risk here. Right? And now you will see that you have this, right? You have the initial duration and you build this with the risk register, the tail. The same thing will happen with the cost. Good thing is that if you resource load, right, your model is that you will get the main two variables that normally a project manager wants into the same model, which is the project duration and the project cost. Normally what happens is that, right, you have your model in MS Project and then you have your cost in Excel. And what we're trying to modify here and to break the assumption that you will have to have two platforms, you can have both integrated. That is why I have this cash flow here. I'm not going to go deeper in that, but I have my cash flow from our project here, which is derived from the results of the Gantt chart, right? So I can have both worlds here. Here, what else I have in the report? For example, I have my NPV calculation. In this case, I have an NPV calculation for the report, which you can generate automatically, right? You can generate the report contingency. That means how much from my NPV I have to add on top of my proposal, of my cost, depending on my level of protection. Going back to the risk register, these 3 cells are key for all these additional tasks to be added. And here what you have again, remember, the mapping to which task you want the delay. So tasks B8, that means that this is the predecessor. So a task is going to be generated here on the file, right? By joining together both tasks and the risk register, you can successfully add this, right? The uncertainty and the risk event impact into your project manager, into your project management. So our suggestion is hopefully you can see both webinar of today, the webinar of yesterday, and take a look on how a project can benefit a lot from the uncertainty and the risk register, because they share the same framework, but obviously the way of doing things is slightly different. So I don't know, maybe I have time for one question, Jameson.
Oh, sure.
Well,
sure.
If you want, you can. I'm sorry, Jameson. If you want, you can email Jameson the questions. We're going to be responding them between this and next week, so you don't have doubts. Please go ahead.
Yeah. That's Goose. I'm going to email you a whole bunch of questions that we probably won't be able to get to. Let me go through our list here. This is an interesting one. Where are the risks in the register linked to the activities?
Oh, here. Let me show you here. Here, as it is really simple. So sometimes you lose the link. It's here. You see, you have the risk project at delay tasks B4. So this is the predecessor. So that means that after this task, right? If you go there, you see the predecessor task, right? After B4, here a task is going to be generated. So you can say that this risk affects site selection, right? This is what is the task that is every risk is affecting, right? Now, if you ask me, can you have risks that affect one or more tasks? Yes. How would you do it? And in the past, what we've done is we first generate an intermediate table, and this intermediate table has some factors. When you say, well, this risk is going to affect 50% of this task, 30% of this task, 20% of this task, and then we add this risk at delay to each one of them, right? Or even you can have some random affections to each one of the tasks. So you can have both, but you will have to create an intermediate table. But that's done, and it works just fine.
Good.
Okay.
Good.
So, well, thank you guys for your time. Thank you for staying there in the line. I think that you have Jameson's email, and well, he has mine. So
yeah, certainly.
So we will be able to respond to your questions. I think this is going to be posted sometime next week, I guess, this recording.
Yes.
And well, happy to be with you during this afternoon. Thank you so much.
Yeah, thank you, everybody. And especially thank you, Goose. We really appreciate it.
Thank you, Jameson. Talk to you later.
Hey, talk to you later.
Bye.
Bye.
Bye-bye.